So in this lecture, we are going to summarize the complete chapter that we have learned. So we'll be summarizing the chapter number 2, whole numbers. So first we learned about natural numbers. In that we covered the definition, and the definition of natural numbers says that they start from 1, 2, 3, 4 and so on. And natural numbers are called so because they have come out from the way we count naturally. The basic properties of natural numbers that we studied are that each and every natural number has a successor, each and every natural number has a predecessor except one which has no predecessor, and the largest natural number is not defined. So that is what we studied about the natural numbers. Now let us see what we studied about the whole numbers. So first we go into the definition. When we add a 0 to natural numbers, then the set of numbers that we get are called as whole numbers. The addition of 0 is very helpful in representing very large numbers. And if we have a look at the way in which the whole numbers are defined, we start with 0, 1, 2, 3, 4, 5 and so on. And having a look at the basic properties, every whole number will have a successor. Every whole number has a predecessor except 0, because 0 has no predecessor, and the largest whole number is not defined. So that is what we studied about the whole numbers. Then we studied the number line. And what is a number line? A number line is a line representation in which we draw a straight line and write numbers separated by unit distances. We also studied the basic properties of the number line, that is, each and every adjacent number is separated on a number line by unit distance, and a number to the right hand side of a selected number will be greater, and the number to the left hand side of a selected number will be lesser than the number that has been selected. We also studied the operations, mathematical operations on the number line, and addition. And when we are doing addition on the number line, we have to move right in the unit steps. When we are doing subtraction, we move towards the left side on the number line in the unit steps, that is step of 1. And when we are doing multiplication, we jump towards right in the multiplier step. So that was our discussion on number line. And then we spent quite a lot of time in understanding the mathematical operations of the number line, and specifically the mathematical properties. And we studied 5 different properties: closure, commutative, associative, distributive and identity property. And we spent quite a good amount of time in trying to understand these properties. So for the closure property, the general meaning of closure property, it implies what is the result when we perform an operation. And how do we check for closure? So we just take any operation, that is addition, subtraction, multiplication or division. Just do that operation, perform it and check whether the result is a whole number. And when this is true, right, that the result of a particular operation is always a whole number, we say that that particular property, that is closure, is satisfied for that operation. And then we found out that whole numbers are closed under addition and multiplication, whereas whole numbers are not closed under subtraction and division, which means that subtraction and division may lead to numbers which are not whole numbers. That was about closure property. Then commutative property. The general meaning of commutative property implies changing the order of operation. That is, we did that in examples. How do we check for commutativity? You take 2 whole numbers, do mathematical operations with the original pair of numbers, then you do the operations after changing the order of the numbers, and then check if the results are same for both the operations. If that is true for all the sets of whole numbers, then we say that that particular operation satisfies commutativity. And based on our examples, we also understood that whole numbers are commutative under addition and multiplication operations, whereas they are not commutative for subtraction and division, which implies that if we change the order of numbers when doing subtraction and division, we will not get the same results. So that was the commutative property. Then we studied the associative property. The general meaning of associative property is related to the grouping of numbers. And how do we check for associativity? We take three whole numbers and then do mathematical operations after changing the groupings of numbers. That is, we take a group of two numbers and do one operation, and then again we change to another group and do that number, and then we check if the results are same for both of the operations. If that is true for for all such type of operations, we say that the particular operation is associative. So we based on our examples, we understood that whole numbers are associative under addition and multiplication, but not under subtraction and division, which means that if we change the groupings of numbers when doing subtraction and division, we will get different results. Then we understood about the distributive property. The general meaning of distributivity implied the distribution of one operation over the another. How do we check for distributivity? We take two numbers, then we represent one of them as a sum of two numbers and then perform the operation. And then we check whether the results are same for both the operations. If that is true, then we say that the particular operation follows distributive property. And we also understood the distributivity of multiplication over addition using an example, and it's very helpful for simplifying the operation. And we also learned that the most common example is multiplication of large numbers, where we already use distributive property without even knowing that we use it. Then we learned about the identity property. The general meaning of identity property implies whether a number is unchanged after an operation. And how do we check for identity? We check whether the number is unchanged after performing a mathematical operation. We found out that 0 is the identity for addition, 1 is the identity for multiplication, whereas 0 is not the identity for subtraction and 1 is not the identity for division. After we discussed the mathematical properties, we discussed about the patterns of numbers, in which we found out how we can observe and utilize the patterns of numbers for simplifying multiplication and addition. So with this I end the chapter. Thank you.